Today, we're diving deep into the subatomic world to tell the story of a particle so ridiculously massive and short-lived that everyone figured it was destined to always be alone.
But what if that whole story was wrong? What if this lone wolf could, just for a split second, find a partner? Okay, let's get into this, because physicists at CERN have just spotted the first evidence of something really, really remarkable.
So, to really get what's going on, we first need to meet our main character, the top quark.
All right, quick refresher. Quarks are the fundamental building blocks of matter. You know, everything you see, everything you touch, it's all made of particles like protons and neutrons, and those are made of quarks.
But here's the thing. Not all quarks are created equal. You've got 5 lighter types that love to team up, forming stable little groups. But then there's the top quark. It's the absolute heavyweight champion of the particle world. It's so massive that it decays almost instantly. Way too fast, scientists thought, to ever bond with anything. It was the ultimate lone wolf of the universe.
And this wasn't just some wild guess. It was a core belief in particle physics for decades. As the spokesperson for the CMS experiment at CERN said, the very idea of a top quark pairing up was pretty much considered impossible. So finding evidence for it, well, that means it's time to rewrite the textbooks.
Which brings us to the next part of our story, the hunt. I mean, how do you even go about finding something that shouldn't exist and vanishes in the blink of an eye?
The key to all of this is the strong force. You can think of it like the universe's most powerful superglue. It's carried by particles called gluons, and their whole job is to stick quarks together. For all the other quarks, this glue works great. But for the top quark, it was always in a race against time that it was destined to lose.
So how did they even look for it? Well, over at the Large Hadron Collider, scientists are smashing protons together at insane speeds. For just a fraction of a second, top quarks pop into existence. But then, poof, they're gone, decaying into a whole shower of other particles. The scientists are basically cosmic detectives, sifting through all that debris for clues about what happened in that first fleeting moment. And this right here is the heart of the problem. You can't see the top quark pair directly. It's kind of like trying to prove 2 ghosts hugged. You can't see the ghosts, so you have to look for the faint, lingering evidence they left behind.
And that evidence, that faint trace of a ghostly hug, is exactly what they found. It's the story of what they're calling a fleeting embrace. This is where they got really clever, with this term quasi-bound state. See, the scientists realized they shouldn't be looking for some stable, long-lasting particle. Instead, they hunted for the signature of a top quark and its antimatter twin, an anti-top quark, having just enough time to exchange a few gluons. Think of it like quick handshake using the strong force right before one of them disappears.
So their big breakthrough was to look for a super subtle clue, the way the spins of the top quark and the anti-top quark were influencing each other. If they were really interacting, even for a moment, their spins would get tangled up, leaving this unique fingerprint on all the other particles they decayed into. And this brand new technique led them right to the smoking gun, the one telltale signature that proved this impossible, fleeting embrace was actually happening.
And here it is. The team found way more events than they expected, where a top and an anti-top quark were created almost standing still relative to each other. Now that's the perfect condition for them to have that brief interaction to exchange those gluons before decaying. It was the perfect little pocket for a quasi-bound state to form.
So how sure are they about this? Well, in particle physics, the absolute gold standard for a discovery is a statistical certainty of 5 sigma.
And what does 5 sigma actually mean? It means the odds of this whole thing being a random statistical blip are less than 1 in 3.5 million. To put it simply, this is real. The loneliest particle in the universe isn't always alone. You know, a discovery this solid doesn't just add a new fact to the books. It fundamentally changes how we understand things and opens up totally new areas of research. It's literally time to rewrite the rules.
So what's the big takeaway here? Well, for starters, it completely shatters an assumption physicists have held for decades. It opens up a brand new way to study the strong force under some pretty extreme conditions. And, maybe the coolest part, it proves that even the heaviest, most fleeting particle in our universe can find a partner, even if just for a moment.
And this is just the beginning. The data for this discovery, it came from the LHC's second run, which ended a while back. Run 3 is already happening at even higher energies. And by around 2030,
The high-luminosity LHC will let them study this new phenomenon with incredible precision. There's so much more to learn. In the end, this isn't just a story about one particle. It's a huge step forward in our quest to understand the fundamental forces that glue everything together. And it just leaves you wondering, what other secrets about how our universe works are just waiting to be discovered?